Good morning and welcome back to Quant Questions, where we go over questions commonly asked in the quant interview. Today's question is colorful cube. Consider coloring the 6 sides of a cube, each a distinct color among the red, blue, green, yellow, purple, and pink. Find the probability that the sides that are colored red, green, and blue all share a vertex of the cube, or corner, in common. I'm going to give you guys around 3 minutes to think up a solution to this problem. Remember, it's an easy problem on probability, so it shouldn't be too bad. But if you need to take extra time, do take it. Don't just jump straight into the solution. Starting with the solution, there are 6 factorial colorings of the sides total, and there are 8 ways to pick the corner of intersection. Now, the first ruling comes from permutations and combinations, and the second comes from basic logic. Now, if you don't know what permutations and combinations are, I'm going to give you a quick overview, but make sure you learn this, as it's one of the fundamentals for your Stats 101 basics. Now that we have this, how do we figure out how many colorings are possible? Well, we see the first colors has 6 options for the faces it can select, because there's 6 options in the cube. The second one will have 5 options because the first one has already took an option. Third one has 4 options, so on and so forth, until we get 6 times 5 times 4 times 3 times 2 times 1, which is 6 factorial, which is equal to 120. Now, NPR is the same idea, except R is if there's a limited number of faces. So say we had 6 colors and only 3 faces to choose out of. Now, I'm going to link a video in the description so you guys can learn more about permutations and, of course, combinations, which are closely related, because it's extremely important. Now, where does the second ruling come from? There are 8 ways to pick the corner of intersection. Well, that's just basic logic, because there's 8 vertices of a cube, or 8 corners that you can pick to be the point of intersection. So now that we have these 2 points taken care of, the solution becomes very easy. So there are 3 factorial ways to arrange the 3 colors along the point of intersection. That's pretty simple, right? Because the first one has 3 options, the second one has 2, and the last one has 1, because the point of intersection will have 3 faces connected to it. Then there are 3 factorial ways to arrange the other 3 colors among the other sides, because there's now 3 faces left and 3 colors left. Thus, our probability is 8 times 6 squared over 6 factorial. Why? Because there's 8 faces, 6 comes from 3 factorial. Divide by 6 factorial as the total number of colorings possible. And we get our solution is 2 over 5. Now, going to an alternative solution, why don't we fix one color on a given side? The second color among blue, green, and red has a 4 out of 5 chance of sharing the edge with the first color. Only the side opposite of the first color doesn't share an edge. So whatever side you pick, only one side won't share a vertex, because the other 4 will. Then after that, there's only 2 of the 4 remaining sides that will share a vertex with the other 2. So think of a Rubik's Cube. If 2 sides are selected, then there's only 2 faces that will end up sharing a vertex. So our probability then becomes 4 over 5 times 1 over 2, which is equal to 2 over 5 again. And you see that if you enter 2 over 5 or 0.4 decimal equivalent, that's a correct answer in Quant Questions IO. So thank you guys so much for watching. Like, comment, subscribe, and I'll see you guys in the next video.